wanted to ask, like, is this the best method? I don't know if anybody thinks this, like, using that Markov chain is the best method for predicting those variables. I don't know. Is there any other method you can use to get those parameters? Because some people, the way the changes in the data is going, it's really scattered, totally, like, it's not going in any normal way at all. So I don't know if there's anything that can be done about that.
Emmanuel, can you write your question, please, so that Yabebal can see it and give you an answer?
Yeah, write your question. I think maybe he's off, but write your question, please.
Okay, is it, can you see?
Yeah, we can see your screen.
So it's not. Let me just make it like that, and then okay. So this is anything that applies this theorem. And why do we do that? Almost always. It's because we always want to write, okay, we have a data. That's where we start from usually. And then the question is, we want to know which parameters of the model, in this case, let me actually make it, instead of I, let me make it model. We also start usually with a model, right? So you have, like, almost always you start, that's what's called start rule number one. Always start with what you are doing. You know, so okay, what you start with is a model and the data. In this case, the SIR model and COVID cases data, daily data. And the model, of course, is has parameters, what is called theta. But we don't know the specific values of theta. All right. So we want to know what are the specific. So we want to, because we don't know, usually we want to know how likely are the difference, because we know the range of them, the range of the theta. So if it is a lambda parameter, it is actually between 0 and 1, right? It's an infection rate. So if it is 0, that means nobody gets infected. If it is 1, everybody who comes in contact with a person gets infected. That's where it's called an exponential. It basically becomes, you know, completely doubles, like, right? So then the question that you really have is that, okay, you don't know that. But then Bayes' theorem allows you to convert this thing into this thing. This is a product rule applied, right, with Bayes' theorem. It basically says the probability of a parameter given a data in a model is the same as the probability of the data given a model and its specific value, its specific parameter value, times the probability of that specific value of the parameter divided by, you know, the probability of observing that data with that model. So this is what we call evidence. That's usually the hardest to compute, because you have to integrate over all the space of, like, that means, you know, if the model is right, if the model is wrong, this thing becomes really gets 0 and 0, right? So and that's kind of like, you know, let's not talk about that. That's the complicated aspect of Bayesian part, is just this part. But most of the time for parameter estimation, we don't care, because this doesn't depend on theta. Because this is a function that doesn't depend on theta, we can ignore it. So that's why usually we get into this equality. If I'm like that. Okay. So yes, with equality sign. So this is like with a kind of not equality, but it's proportional, and we don't need that. Okay. So that's why this one we can remove that by taking this one as equivalent sign. So that means it doesn't depend. So it's just a rescaling. It's a constant normalization factor. Okay. Any question? I think I'm not seeing, so I can't know. Would you please start recording? Ah, great. That's already started. Okay. So is that clear?
Okay, I have a question, sir. Can
Yes,
I ask a
go on.
question, sir?
Yeah.
Okay. So what if our model, like the premise of the model is not good in the first place? I don't know.
Then you are doomed. There is nothing with a wrong model, you can't do much. That's where I said the evidence is called this one. Of course, in principle, this should be compared to another model, this should be smaller. But yeah, like if you start with a wrong model, Bayesian doesn't help you much.
So what can we do about that, sir?
No, you don't. It's like you go and, you know, you build more models. That's why we need more models. So that's a scientific approach. You don't rely on one model. But this model was chosen because it kind of worked for many years, not just today, not just for Corona, but it worked for many, since 1908, whatever, the first time that they, whatever, introduced it. Since then it has been used and tested, it kind of worked. So of course, we know that SIR model is a good representation. It doesn't incorporate everything, but it's a good representation. So it captures the dominant effect. But yeah, like if you start with the wrong, that's why, for example, for some countries, the data is so complicated that actually the SIR model doesn't work. So for example, for a continent like Africa, generally the population lives in a very different area. And so the rural part of the country and then the urban part of the country are have different contact rates and stuff. So you have to separate the data to actually really get a good understanding. So that's why I would recommend, if you have the access for your country, for the big the capital cities, whatever, try to use that instead of the data that you get from JSU.
Like, okay, so how can we add more parameters to the model? Like,
No,
I
it's
noticed the guy added some parameters. Like,
you could, but the problem is that it's you can't do that in 1 week. It's quite complicated. So
because the parameters, like, they are not working in my favor. I don't know what.
in my favor, no, it's not. They are a good representation. So it's what you are saying is the data is not clean. So the two things are either you make the data to get closer to the model, or you make the model closer to the data. Okay. So sometimes when you have a very complicated model, for example, that you have in a country where the testing is very small and that it's dominated by people coming from outside, like if the country doesn't have community spread, what is it called, but it's called imported, then this model is not capturing that. This model is not about imported cases. This model is about community cases. Once the community started spreading, once the disease starts spreading in the community. Is that clear?
Okay, sir. Okay, sir. It's clear. And also, so I wanted to know, with regards to those parameters, we are inferring from the
Yeah.
data.
Yeah.
So, like,
This
how
one.
can, like, I wanted to know, like, how should we go about getting those parameters? Like, I don't have any idea about the country I am using here. I'm using Egypt, so I don't know how can I get this what are the
No,
ideas?
but you don't need to do that. The code already does that for you, right? So what does it do? The code, you start from the code, you get,
the code gave me some parameters, but I don't know if it will work with what
I think it's fine as long as you use the data. I mean, the first thing to know, the only thing I would say is that if you guys don't see the data yourself, how play with the data, then you are not a data scientist. If you just go into modeling without looking at the data, without plotting the data, then there is a problem. So for example, that's what I am saying. This is, for example, for Ethiopia, and I need to plot it, right? So I have to just, okay, I got the Ethiopia case. Let's say just this one. Then I will just say df then plot, just at least I want to see. Okay, maybe it's not there. So then I will say, okay, so this is February to August. This is the number of cases, and I must make sure I have to go to the internet to check if this is correct. Then it's great. So this is the cases data, confirm it. But I could also, if you look at, in Python, the good thing is that if you just, okay, so if you are like, I can just, because JHU, I can do this and I can get, what are the available ones, right? So, okay, there are many available ones. So in this case, let's say I want the days, right? So days, then again, I can ask for Egypt, whatever, but let me ask just for Ethiopia again. And then, okay, DFP. So then I get, okay, so this is the kind of the increase. So it's okay, So then I will ask, like, when is the time it got starting from 100? Because at least it's reasonable to assume the first 100 are probably more important. And then it's only from then probably it started becoming community. So yeah, and then I get this data, I play around, I clean. That's where thinking is. That's what, as a data scientist, you just don't go think about, okay, what is, like, I want the data that is like clean. And then once I have that, I just go, and so I edit. So this is, I don't need this in that case, right? Because this is, so in that, for me, it would be total cases So let me just, I can modify that one part as well. So instead of RKI, I'm not, RKI is for Germany, but as I showed you, I'm using JSU, JHU. JHU is the what is it called?
John Hopkins.
Huh?
John Hopkins.
John Hopkins, exactly. It's the John Hopkins one, which contains for the global one, while RKI is the German Institute thing. So I don't want to use it. That's why I use JHU. Okay. So I use JHU, and to know what are available, you can add even your own country. If you look at there, you say you can get a lot of things. So you can go, I mean, so there are some from Google, Ireland, JHU, Latvia, blah, 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 Portugal. But, you know, your country is not there. You can, if you want, you can actually add for your own Ministry of Health. But that's not the question, okay? Sometimes things are, I'm just saying them for the sake of like, if anyone is interested, but don't try to do them because everything takes time. Know that. One thing you have to know that every effort takes time. And sometimes if the effort pays off, great. But if not, you know, just go and proceed. So that's why I use JHU. So, and then, so I don't use RKI. So I'll just here come also JHU. And then value confirmed and data began date and whatever. I will just like take that, remove that, confirmed, and again JHU because that's what I know, like that's basically this parameter JHU. Okay, and this is where the choice, what you are talking, what you are asking is that since when should I plot? Since when should I get the data? So this is the beginning date and ED is the end date, and you should just know. And so this is saying end date is from up to now, but no, I didn't want up to now. I was specifying for you to do right? So to do something more specifically up to probably August. And so this is where I have to look. What is the first, you know, when did the country get, the Ethiopian case, for example, when did the country get? So just let me print it, PDF. Then I will see, you know, that up to even a certain time, it was actually 00. So I will just gonna be like, okay, if greater than, let's say 100. So, okay, and I will just also remove DF now, and okay, so just let me. It's maybe it's a daytime in the index, and then none is int exactly. So what is name state. State. So let me if right. So so the time that for Ethiopia to get more than 100 is 1804. So I can probably choose that, right? So I'm just gonna be and so then I will replace here. It's the when is the date? It's 1804, for example, right? So it's 4 and 18. Okay, so that's what I would do. So now I change this one and I go to, let's see if everything works. So total cases, beginning, end, end. Just I'm just gonna, okay. So just type. And it is not defined. So that's where, like, when you are learning these things, you are basically just, oh, I didn't. Orig is not defined. Where is orig? It's body confirmed, date begin, date end, and that's in their code. So I would just go and fix their code, get new. But in the case, otherwise, what I will do is just that I know what they are saying. Get total. So what I will do is just usually I will go and fix even their code if I see something is not working. But in this case, just let me see. So what I want to get in this case is the total cases and the new cases, right? So of course the new cases I can also just try to get to circumvent their code and just go around and get, okay, the total cases is exactly what I call df. So df is the total cases. So I'll just use the same variable. And then the new cases is basically just the cumulative difference, right? So it's kind of is equal to df 0 to whatever minus df 1, right? So this would just should give me the 0 to minus 1, and so let's check if that is correct. So new case, oops, I so that is not true. So, dot cumulative. So another way I would do is why is that not working? 1, 2, 0. So, but what I need to do is that to take a difference, because this is a cumulative thing, as you could see.
Sir, I will share the code I used for that now, sir, to get the difference.
Sorry?
I will share the code I used to do that, sir, now in the group, sir.
Sure.
For the I shifted it. I just did a shift here, sir.
Okay. So what do you do? So you do.
Let me share it on the group now, sir. Okay. That was the code I used, sir. I posted it on the group now.
So where am I now? That's the problem. It's not. I'm not getting. Yeah. Great. So if I do, then what you're saying is shift 1. So, but I need to know. So there's still why because I didn't use this one, diff. Okay, then this should work. Okay. Yeah, so but what I would do is that I will make sure that this thing is correct every day. I have in the, I would just go and check that for each of the days that I actually have the numbers right, that it is for the 19th of April, the Ethiopian case reported is 105, for the 20th it's 108, like that. It seems not reasonable, so I would go and verify. But that's basically what I am going to do in terms of getting to a point where, like, okay, I have a data that I trust, and this data represents the kind of the model I'm trying to do, because the model really, and then this is the prior, like the priors on, this is where you set the change points. So it should be significant. Okay, so that's. So what is this parameter? You probably, when you read it, you kind of will know what is the difference. I think this should be significantly larger than the expected delay. So this is the number of dates that you should go, like on the first date when you're trying to predict. Of course, the patients that got detected or they kind of get infected or test positive at that day didn't get the virus at that day, right? They got it some time ago. And so you have to set that kind of the data and the simulation difference some time ago. So this is where in their paper it's explained. So it should be whatever. So it's kind of you should give it some number. So you can let it at 60. So this is to tell the model generates at that day, given day, while the data is shifted because a person gets infected, but there's kind of the delay part. Then they have to go to the hospital, they need to be tested, and then the hospital has to process that and have to announce. By the time it's announced that one person is positive, it actually means that person had interaction with another person some time ago. So that's why you need to introduce this one. And then the change points, you basically, you can read, these are the setting how priors work. And I think you don't need to change most of this in understanding sense. It's basically, you are setting 3 dictionaries where it's a log normal you are setting. It's a log normal prior, and the prior has date, transient, it's 3, and then it has median 0.2 sigma, blah, blah. So that's their definition. So you just, that's what he explained, 1/8 the date in some of them. So these are just all priors. I'm kind of, I will go through tomorrow in more detail. I think once you actually go through and you have a question, I'm gonna go with you together solving it. Okay, so that's what makes it good. I don't try to, I want to get exactly where you could get. Of course, I have an advantage of understanding it, but in terms of the work, we are gonna get, and I'm gonna evaluate you how much you did based on how in each of us in the tutors are actually working with you together. And this is the kind of the PyMC part. PyMC, so the model is encoded in this COVID model class, and so you instantiate it and then you provide it. Again, you provide, all of it is commented. If you don't understand, this is just really following the paper. You kind of give prior, you specify the model, and you give this new IT, blah, blah, all these are names. And then, you define every other thing and the model just runs and you get somewhere. It's like, and MCMC sampling is where now the model, this is up to this point is model definition. You basically translate their paper into defining it. You haven't yet started kind of computing here or fast, just nothing. But then here is where you start the kind of so that's where draws, whatever, what I said, you can change it. You can make it to 100 such that it's kind of gets quicker, so when you run it, it's kind of gets quicker. And of course this, basically you try to understand this model is what is defined here as this model. This is just the with, in Python, with basically gives context. So that means whatever defined here will be inside this model. And so you can always use this model to do stuff. So that's the part. And then after that, it's plotting, distribution. I mean, basically that you will see. And I think, like I would say, just gate somewhere and find a specific problem that you have, and then we will build on top of that. Any question that?
Is this the only file that we're concerned about?
Oh yeah, for most of your part, it's this part. And then the data analysis part you do is the data analysis part is like the data cleaning. If you want, definitely. So the real aspect of this project is that the code is there, but it may have a little bit issue, very little issue. We will fix that. We don't ask you too much on that. But I really want you to understand the paper and what you are doing. So not per se the code. I think the code, just make it run, make it do something, understand where to get something. But understand what is the flow, like, why do we do this? Why do we model that? And understand the modeling, how the model and the data puts together in such that you get a result, how the model parameters are there, and estimate the model parameters, and then predict this, for the test case. And it's the understanding. This week is a lot more like, it's 1 week. We don't try to understand everything. So the code, just make it run. That's the whole point. Just use your Python knowledge to run a code, and to try to just ask a relevant question to make it faster for you. Like, okay, it's taking, hours. Can I make it faster? Kind of only on that aspect. So, and then of course, plotting. You can, once you get the result, plotting, blah, blah, exactly following the paper, try to reproduce some similar plots with the paper. But the real aspect is really understanding what is going on. And then when you introduce your own data, the country that you are working, you have to really look at the data. And you have to understand, if you understand the paper, you understand what it means. Okay, does my data actually really fits there? If not, how can I make it fit? And then it's an iteration process. So that's the whole question, is also like set with the understanding in mind, not the code in mind. If you look at the description of the challenge, it's a lot more setting on your understanding more than on your so on the kind of analysis aspect, coding aspect of it. This is more understanding aspect. Is that clear? Any question? Does that mean clear, right? Okay, great. And yeah, play around. You know, we have everybody, including the author of this code, helping us. He will give us talk tomorrow. What is the interpretation, Adnan? I didn't. Adnan, do you want to say? Yes, mulu work. Yes, it is. It's kind of, because if you look at what is the mechanics of it, it's kind of, you have a number of agents, and then these agents interact with each other, and of course it's like, and then these agents have 3 states. One state is being infected, the other state is recovering or dead, you know, that both in the same thing called removed. So anything, of course, that falls like that, you can use SIR if your system, but it is a good one for infection, because you interact, and in one you get infected, in the other you get, you know, you kind of recover or die. Yeah. So Gerald question: could the Google Drive folder for the week? Is it not? It is. It is. How did you get then the papers and stuff? It is shared in that folder. Jean, could you share that?
Which folder? Okay, the today folder.
The Google, the G Drive, the week 3 folder.
The week 3 folder. Okay, I will share that here.
Yeah, just because it has all the papers and kind of the presentations, blah blah, from so far. Yeah, okay. I will share my notebook. This is just exactly the one I modified. I will try to get to comment a little bit more on it, just to say like, do this, I mean, whatever, then I will share it. Which block of code takes care of the forecasting using the test set? Okay, that's, where is, so once you have the data, so that's called, this is exactly what you are specifying. You are on top of, you are predicting on top of the paper. Sorry, on top. So these are data points, and these are the model. The green is the model, right? So and if you look at this model trace offset, okay. I don't think I have run it, so I wouldn't know. What is the best way? Nope. So if you look at the code, so in the model data retrieval, then I think there should be here. So this is the model that you are kind of taking. So that's where the abstraction. And if you look at it, so this is where you would specify the forecasting lengths. Okay. So that's basically when you specify in the model, there is a parameter called forecasting. I think there is somewhere there a forecasting date that I had to specify. So this is the delay, but yeah, number of days to forecast from the data. Okay, so you would specify up to a point. This is the end date, exactly we talked. So the end date is the one, the model is gonna be trained with that. And then you ask it to predict for a number of days starting from there. Is that clear? Hang on. It doesn't help me. It's yeah. Okay. Yes, it's clear. Great. Okay, I just couldn't get here easily. Okay, so I think with that we can stop. And any questions in Slack, please, guys, just write your understanding, create discussion, and make it active, because this is conceptual. This week is a lot more conceptual, and I want you to get the basic idea. And after that, of course, you will learn the core knowledge. You will learn it when you are at work. It's like when you need to do it, you will do it. But by just discussing and crystallizing this knowledge and this discussion, by talking about it, whatever, even organize within yourselves, like the Google Hangout, and kind of don't leave this week without having a kind of a rough idea. It's kind of like how you would translate it to another project. That's my measure of that your success. I would say you would succeed only if you are at least able to dare to translate this thing to another problem. It could be the the Twitter thing that I mentioned there, kind of the corruption, but on another thing. If you are able to do that, if you can just go through that for another problem, that means you kind of got it roughly. That's great. So just aim for that, and all the best till, and then we will just be in Slack. So this afternoon I won't be probably connected, but Jai is there, and yeah, like I will be back later tonight. If there are any things that concerns me to answer, I will answer. I'll share with you. Great.
Yeah. So Yabia, will you share, as this notebook is like more details, you provide some comments? So
yeah, I will just share it as it is now, like in
Yeah.
the thing. But then if I have time, I will just add comments and
Okay.
share. But whatever
so-
it's now, I will just share
Yeah.
it.
Okay, so basically, this is the only one notebook they need to actually solve the problem, or because I saw in the GitHub channel, I saw in the GitHub a lot of notebooks, so I
No,
don't
I
know.
think this is, I mean, all of them are very similar, but this is just the one notebook, which is called, the name
Yeah.
as you,
Yeah. Okay, so please share this in the.
yeah, so the name is called example one Bundes, whatever. So
Okay.
but I will share it. I will just put that one in the folder.
Sure,
in the
sure.
folder.
Sure. Thanks so much, Javi. Yeah.
Thanks a lot, guys, and all the best. Cheers.
Yeah. Let me stop. Cheers.